Hey everyone, welcome back to the channel. Today we are going to look into something really cool, which is identity verification with Amazon Rekognition. Whether you're trying to find a specific person in a crowd, verify identity across images, or scan through hours of video to locate someone, Rekognition makes it surprisingly easy. We'll be showcasing a real app that does exactly that, analyzing both images and videos to detect and match known faces. And as always, if you're looking to build a custom solution like this for your own use case, Codersarts can help you bring it to life with tailored expert support. So let's jump in. But before we move ahead, let's try to understand what is Amazon Rekognition. Amazon Rekognition is a powerful image and video analysis service offered by AWS that uses deep learning to identify objects, people, text, scenes, and even activities in visual media, all without requiring you to build or train your own machine learning models. It's designed to make computer vision accessible to everyone from startups to enterprises with just a few lines of code or simple API calls. So what exactly is face matching? With Amazon Rekognition, face matching means identifying whether a face in an image or video matches a previously known face. It's kind of like a facial recognition but focused on comparing with a set of known people. There are two main ways Rekognition does this. The first is image to image matching, where you directly compare two images to see if the same person appears in both. It's super useful for ID verification or duplicate photo detection. The other way is searching known faces in videos. This is where it gets even cooler. Rekognition lets you store known faces in a collection and then can scan entire videos to find if any of those faces show up when they appear and where exactly in the video. It's powerful stuff, and what's amazing is how much of the heavy lifting AWS handles for you. So now let's see how that looks in action in our next section, which is demo. So let's begin with the fun part where we'll see face matching for identity verification in Amazon Rekognition. So we'll start by running the app. I'll open it in the browser. So this is the interface of the app. It's very simple and basic and very easy to understand. So here the main API that we use from Rekognition is compare faces. The idea is pretty straightforward. We supply two images. The first one is the reference image that contains a known face which we want to find in other images or videos. And the second image could contain the same person or multiple people. This is the target image. So these are the two images that would be required. Basically the reference image and then a target image or video. Alright. Here we need to make sure that the reference face image that we provide is pretty clear and the face is fully visible. So let's just go ahead and upload a reference face image. So I'll be using Reese Witherspoon's image. Alright. So here we have uploaded the reference face image, and then now we need to upload any target image or video. Now the target image or video may or may not contain the person whose face we have uploaded in the reference face image for the purpose of identity verification. Alright. But for the purpose of this video, we'll be using target images or videos which do contain the reference face image so that we can see how it works. So let's upload a target image as well. Okay. So I have uploaded the target image also, and now we just need to click on start detection, and here Rekognition does the heavy lifting. Alright, and you can see that it took 1.15 seconds to match the identity of the person in the detection results. Alright, or basically in the target image. This was the target image and this was the reference image. Now reference image, we can clearly see that Reese Witherspoon's face is fully visible in here, and Then let's just open this in the new tab so that we can see it properly. So here this face have been matched, that's why the bounding box drawn around it is green in color, and for the other faces that were detected in the image, since they were not a match, the bounding box has been drawn as red. Alright, and the similarity score is also present in the case the face was matched, and here it was like 99.91% sure that this is Reese's face. So you can see the accuracy behind it as well. Alright, so again in here we have the analysis result as well, which shows that 7 faces were unmatched, only 1 was matched. And here in this table we can see more of the information around here as well. Basically the type, whether the face was matched or not. Index, now index here is basically the numbering that is used for the images in here, all right, that were detected. So just to keep track of various faces in the image. Now similarity here is how much the reference face is similar to the face in the target image. All right, so this is that score, and confidence is how much the model is sure that okay, these two faces are same. All right, so basically the confidence score is 100%, and the similarity score basically is a technical match between the reference image and the target image in terms of their similarity. That comes out to be 99.91%. all right, then we also have the dimensions for bounding boxes and brightness and sharpness of the faces in the image as well. All right, so basically if we have let's say index 2, so the second face in the image that is recognized by Rekognition is having a sharpness of 12.84 and brightness of 96.8. so that's how these results are to be interpreted in here. But that's not all. We can also get the details for facial landmarks like the position of the eyes, nose and mouth also. And these image quality details aren't just for show. I mean, they can actually help fine-tune your system. For example, if you only want to compare high quality faces, you can use the quality data to filter results. And what makes this feature so powerful is that it can be used for more than just matching. You can actually use it to identify people in images, whether you're working on a photo tagging tool, an access control tool, or even verifying identities in old photographs. This has real world impact. Let's just try out with another image. Again, we'll use Reese Witherspoon as a reference, but we'll have new target image this time around. Again, the processing time is 1.06 seconds. We can say that it took only 1 second to find the match. And here you can see here in this case that these two faces seem to be very similar, so these two have been matched. All right, now but you need to see the similarity score also that is provided by the model, and here, which is the actual Reese Witherspoon's photo in this target image, it is having a similarity score of 99.98%, and here the other face is having 79.31%. I think it's a daughter. So here what needs to be done is we need to look at the similarity score also to make the judgment of identity verification. So we can design the identity verification in such a way that if the similarity score is more than 99% or basically more than 98%, only in that case we'll call it a match. All right. So this is just a conditioning that can be done, because again there are going to be some faces which on technical level would be similar to each other, but then again we have the similarity scores to define that. So here we can see that we had two matches in here. One was having a similarity score of 99.98%, which is actual Reese Witherspoon's image, and the other one is 79.31%. all right, so this gives an idea that okay, the other face that is detected which have been matched in here is more likely not Reese Witherspoon but somebody that almost looks like her. So that's how it goes. Again, these details are downloadable as well, and we can even download the target image also. Now let's just try out it in a video. So now I'll upload a short clip. Now it may take a little bit longer when we are dealing with video clips, all right, as compared to images. So that's a given. Let's wait. So it took 45.65 seconds to process the target video to find a face match in it, all right, and the target video is 22 seconds long, so the time taken for processing is justified. Also, in order to recognize videos in Amazon Rekognition, there is a slight catch. We'll need to create a face collection, all right. So collection is basically a searchable database of known faces, and we can then index faces into this collection using index faces API. So you can think of it as a database of all the known faces that you already have and want to analyze in the video feed. Once you have this kind of database, only then you will be able to verify identity and compare faces in videos. For images, that's not necessary. You just need a reference face image and that's it. But for videos, you first need to make a collection. So that's just the slight difference in there. And once the collection is set up, then we use the start face search API to kick off the process. So we pass in our videos which is stored on S3 along with the collection ID, and Rekognition begins scanning the video for matches. In this app also, as soon as we upload the target video, first upload it into an S3 bucket, because only then Rekognize would be able to process the video feed. All right. So let's take a look at the result first, then we'll discuss further. So this is the video. You can see that it is detecting Reese. This is Reese Witherspoon, and she, like, her face has been matched in here. You can see the green bounding box appearing in here. All right, with 99.9% similarity score. Some angles it is 98% similarity score as well. It keeps varying because she's not stable in the video, but you can see that it correctly identified her. So let's take a look at the results that we get. So here the analysis results are on per frame basis. So total detections were 100 because this is a 22 seconds long video and there are a lot of frames which are comprising in here. See, 45 frames with faces were there, and video duration is there, and then 37 matches out of 100, because again there are 4 people sitting in there and it keeps on adding in each of the frames. So that's how this count is here. Then this is the complete detection data. Here we also have the timestamp, as you can see, because this is a video, and then person ID is there, whether the face was detected or not, that's also there. And then the confidence score also, you can see that wherever this is true that the face was matched, the confidence score for it was 99.98%, or basically the similarity score. And then we have the dimensions for the bounding box, then a little bit about the pose of the face and yaws and pitches, and then brightness, sharpness, match similarity, and so on. And this is also downloadable, and we can download the analyzed video as well. So this API by Amazon Rekognition is incredibly useful if we are building applications like security systems or media analysis tools or even event coverage apps and such. And the beauty of Rekognition is that it handles all of this complexity for you. So you can focus on building great user experiences. So that's it for the demo. We have seen how we can match or identify faces in images and videos. Again, for images, we just need a reference image where the face is clearly seen, all right? And then for videos, we first need to create a collection, which is simply a database of known faces, so that we can verify the identity of people in video feeds. Also, this video is just a clip and it's not a live stream video. So if we are going to use live stream videos, then then we'll need to use a few more services provided by AWS. So that would look like a different thing in terms of technical implementations, but the results would remain the same. So let's move ahead to the next section of the video. Now, let's talk about pricing, because while Amazon Rekognition offers powerful face matching capabilities, it's important to understand the costs so you can plan your usage effectively. And the good news is you only pay for what you use. There's no upfront commitment and no minimum fee. Pricing is broken into two main categories, which are image analysis and video analysis. So let's explore each. For face comparison in images, which uses the Compare Faces API, pricing is very straightforward. It falls under Group 2 of Rekognition image pricing, and you are charged per image processed with tiered rates. Now, these tiers have been defined on a monthly basis. So, for the first tier, which consists of first 1 million images, you will be charged $0.001 per image in a month. And in that same month, if you exceed the limit of the first tier and move forward with processing more images, then up to the limit of the next tier, which is the subsequent 4 million images, you will be charged $0.0008 per image in that month. And so on. You can see the information of the tiers in the table on the screen. And as you can see, as the number of images that you process in a month increases, the pricing would drop accordingly. Now let us try to understand how the calculations for the pricing works with an example. So if your app processes 2.5 million images in a month, then the total cost that you would incur would be $2,200 per month. Alright, and this is how the breakdown goes. For the first 1 million images that you process in that month, you will be charged at $0.001 per image. Alright, but as soon as you exceed this tier and move ahead with processing further images, that is the subsequent 1.5 million images, you will be charged at $0.0008 per image, and this is how you will end up with a total cost of $2,200. So this service becomes cost effective, especially as your usage grows, with better pricing as you move into higher volumes. Now, for video-based search, where we detect and match faces using a collection, the pricing is per minute of video processed. And here is how it works. Face searches in videos cost $0.10 per minute of video analyzed. So, if you want to analyze a 100-minute long video, then you will be charged with $10. And if you want to work with live video streams via AWS Kinesis, pricing differs and there are additional charges for Kinesis video streams. So be sure to check AWS pricing details if you're planning that route. Also, there is a free tier. If you're just getting started, AWS offers a free tier for the first 12 months after account creation, where you get 1000 images per month for free for face comparisons. However, this does not include video analysis or collections. So, if you're experimenting or building a proof of concept, the free tier can help you get going without upfront costs. Now, let's take a look at some real-world use cases where face matching with Rekognition can be a game changer. So the first use case is security and access control. One of the most common applications is for security systems. Let's say you are building an access control system for a building or event. With Rekognition, you can easily compare the faces of people trying to enter against a database of authorized personnel. If a match is found, access is granted. This kind of technology is used by companies in high security environments like offices, banks, or even airports to ensure only authorized people get through. Another use case can be in personalized user experiences. For apps that need to recognize users, recognition can be used to identify people in photos or videos to create more personalized experiences. Think of a smart photo album app or a social media platform that automatically tags people in photos. Recognition can not only identify the person but can also sort images based on recognized faces for easy retrieval later. Another use case is in content moderation for user-generated content. If you're managing a platform that allows users to upload photos or videos, like social media or video sharing platforms, face matching helps identify known personalities. This is useful for things like automatically detecting and moderating content related to celebrities or public figures, which might require special treatment like copyright or privacy concerns. Another very important use case is in event tracking and recognition. Imagine a video surveillance system monitoring a live event. Recognition can detect and match faces in real time from the video footage, whether it's for sport events, conferences, or concerts. It can help track individuals' participation, identify VIPs, and even locate people in crowds. Another use case can be seen in law enforcement and criminal investigations. In law enforcement, recognition can be a vital tool. It can assist in searching for suspects in surveillance footage by matching faces in public cameras or private security systems to a database of known criminals or missing persons. So as you can see, face matching with recognition has tons of potential across a variety of industries, from enhancing security to providing more personalized services. The possibilities are vast. And that brings us to the end of today's demo on identity verification with AWS Rekognition. If you're looking to implement face matching technology in your own application, whether it's for security, personalization, content moderation, or any other use case, don't hesitate to reach out to Codersarts for a customized solution that fits your needs. A team of experts can help you design and integrate recognition into your systems seamlessly. You can find all our contact details on the screen now, so feel free to drop a message anytime. Before you go, don't forget to like, share, and subscribe to our channel for more videos on how to leverage powerful tools like AWS Rekognition to build intelligent solutions. If you've got questions or suggestions, leave them in the comments below. We'd love to hear from you. Thanks for watching, and we'll see you in the next video.